welcome to the Geomestic channel. Today's lesson will be a first glimpse into the study of plane geometry or Euclidean geometry, specifically focusing on the concept of points, lines, and planes. If you'd like to follow along with this video and take some notes, you can go down to the description below and print off a guided notes worksheet. Now, in order to study Euclidean or plane geometry, there are a few basic ideas that have to be accepted as true without any type of proof. Now, we do this to lay a foundation for statements and concepts to come that will require a little bit more digging. So as you work your way through the subject of geometry, you'll find this underlying trend of having to provide proof for the statements that we make. These statements are generally called theorems. Now, before we get too far ahead of ourselves, let's cover a few basic definitions that mathematicians have generally accepted as true so we can lay that foundation. So the first definition that we're going to talk about is the most basic building block of all geometry, and that is what we call a point. And a point, the definition, a point is simply just a location in space. Okay, we have to be able to denote these, and to do that, you're going to see usually a dot, and a dot, even though it does have thickness, a dot really has no thickness, it's just a location in space. And we use capital letters to denote points so we can distinguish between maybe multiple points in one general location. Now, if you take 2 points and you connect the two, you get what we call a line. And a line is a series of points that extend in opposite directions without end. And that last part there, without end, is kind of the biggest deal here. So if I have 2 points, say the points are A and B, and I connect the two, I go through each point like so. Okay, that line does go on infinitely in both directions, which is why we put the 2 little arrows on either side. Okay, so this line goes infinitely in both directions without end. It continues. So there's a couple different ways to denote or to name a line. One way is with the points that are on that line. If we have just 2 points on the line, it makes it easy. We take those 2 points, AB, and we put a little line with the arrows over the top. Now, it doesn't matter if it's AB or BA, we can really denote it either way. If there are multiple points on that same line, maybe there's a point C or a point D. Okay, because a line is infinite in both directions, it doesn't really matter what points we pick, we just choose 2 and put that line over the top. So I could say this is line DC as well. Okay, so there's a lot of different ways to name a line. Just pick 2 points, put a line over the top. Another way you might see it, if you see a little capital, or a lowercase letter out to the side, if you see this little lowercase n, we can also denote this as just line n. Okay, so either of these ways, and many more, are perfectly acceptable ways to name a line. Now, if we have points that are all on the same line, we call these collinear points. So collinear, the word collinear, co just means together. And linear means line. So collinear points are just points that are on the same line. All of these points would be considered collinear. In the third term, we got point, we got line. Next is a plane. A plane is a flat surface with no thickness. So you can think of a plane as like a flat pane of glass, rigid, doesn't bend or curve, just an infinite flat surface. Like a line, a plane also extends forever. Because we're drawing on a 2-dimensional board here, we'll just use a 4-sided figure to denote a plane, but really this plane, just like my board of glass, if it continued to go on forever, it would be flat forever infinitely. And inside of a plane, you can contain many different points and lines. So maybe there's a point X right there. Here's a line, call it B, W, maybe another point down here, a Y. So a plane can contain many different points and lines. And we have to be able to denote multiple planes too. So we have ways to name them. Usually we see 3 points. So if I say plane, pick 3 points on the plane, say X, V, Y. I could pick another 3, maybe W, V, X. And sometimes you might see in the corner a capital letter without a point on it, just a name of that plane. So I could also say this is just plane P. Okay, so any of these ways are perfectly acceptable ways to name that plane right there. Now, any points that are in the same plane or contained within the same plane, we call those points co-planar. So again, co just means together, planar means plane, together in the same plane. All of these points would be considered coplanar points. Okay, so now we have a working definition of these geometrical building blocks of points, lines, and planes. Let's make a few statements that should feel very intuitive. These following 4 statements are what we call axioms or postulates, which are statements that are just accepted as fact without any proof. And again, these should make sense once you kind of see them and hear them. First one is that through any 2 points, there's going to be exactly 1 line. So again, we're thinking plane geometry, we're on a flat surface. If I were to draw any 2 points in space, so there's 2 points, A and B, there's only one way that I can connect those 2 dots. There's one line through which I can draw those 2 points. Okay, so through any 2 points, there's exactly 1 line. I can't draw any other line than this line to get through those 2 points. Okay, so the next postulate is that if 2 lines intersect, so if 2 lines cross, intersect just means to cross, so there's a second line. We'll call that line M. So if 2 lines intersect, they will intersect in exactly 1 point. So you'll never have 2 lines that cross multiple times because, again, lines are rigid, straight, they go on forever in both directions. So through any 2, or if 2 lines intersect, they will intersect in exactly 1 point. So we'll call that point C. It is possible for 2 lines to intersect on all points, and that's if they are the same line. So if I were to draw a line AB and then draw another line right on top of that, they would intersect on all the points, but then they're just the same line. So through any 2, or if 2 lines intersect, then they will intersect in exactly 1 point. The third postulate is that if 2 planes intersect, which is kind of tricky to draw. So there's one plane. I'm going to draw another plane here. See if I can make it look like they cross. So let's say we have 2 panes or 2 sheets of paper or sheets of glass that cross each other. Kind of one goes right through the other. 2 planes are going to intersect in exactly 1 line. I'm going to draw a picture here in a second that is going to make this a little bit more apparent, but 2 planes cross, they're going to cross in an entire line. So anywhere on that line is where those 2 planes intersect. Not just in one single point, but an entire line. So 2 planes intersect, they will intersect in exactly 1 line. And finally, the last postulate is that through any 3 non-collinear points, so if I have just 3 random points that are non-collinear, so I don't want to make a third point extending here, I want to go kind of somewhere else. Through any 3 non-collinear points, there is 1 plane that contains all 3 of those points. Okay, so through any 3 non-collinear points, there is exactly 1 plane that can contain those 3 points. Okay, so those 4 postulates are all accepted as true, and those are going to kind of build the rest of the core of geometry. Any statements that we say, we can assume that these things are going to hold true. Okay, so some examples here. I'm going to draw kind of a three-dimensional box, at least the best I can. There we go. Okay, so the corners of the box, we're going to put a letter on each one. So we got 4 points at the top of the box, 4 points at the bottom, and I'm going to put a little random point here on the side. Okay, so my box here is made up of 6 planes. We got the top and the bottom, we got the left and the right, we got the front and the back. And the planes kind of intersect one another in the lines, some of which intersect one another. We're going to get a couple examples here. So first is I want to name the front right vertical line. Okay, front right vertical line. Vertical means up and down. The front right vertical line. You should see 2 points on that line. And again, through 2 points, we can name the line maybe a couple different ways here. See, the 2 points are C and G. So to name that line, I can write CG, or I can write GC. Either one is fine. So the front right vertical line would be GC. Okay, second example. I want to name the bottom plane. So the bottom of the box, I want to name the plane that represents the bottom of the box. So remember, naming a plane, I need 3 points. I've actually got 4. So I'm just going to pick 3 of them. So the bottom of the box is here. We're going to say H, G, F. So plane H, G, F. Another way, we could also say E, F, G. And there's a few more. We just need 3 letters. Okay, example number 3. Let's say we want to name, let's name 3 let's go with collinear. Let's name 3 collinear points. 3 points that are collinear. If you remember collinear, that just means that they are on the same line. 3 points on the same line. And hopefully you notice this is why I put this little extra point I. 3 collinear points, D, I, H. D, I, and H. So those 3 points are all on the same line. Those are 3 collinear points. Okay, number 4. Next question is, where does the front right side of the box intersect the top right edge? So again, where does the front right, we'll say corner. Let's start with that. Where does the front right corner, so front right corner, I'm talking about this line CG that we looked at in number 1. Where does the front right corner intersect the top right edge? So we should be looking at just one single point here. Where does the front right corner of the box intersect the top right edge? And that point, right there, C. Okay, so a line intersects a plane in just one point. Point C. Last one. Where does the bottom of the box intersect the back of the box? Bottom of the box intersect the back of the box. So now we're talking about 2 planes intersecting, And one of those postulates stated that two planes always intersect in an entire line. So the bottom of the box intersects the back of the box. Here's the bottom and the back. This is where they cross right there. And you can see that line is EF. Or FE. Alright, that'll do it for this lesson on the geometric building blocks of points, lines, and planes. If this video was helpful for you, feel free to give it a like and subscribe to the Geomestic channel if you would like to see more videos like this. Thanks for watching. See you next time.